if you build with models. This matters because the bottleneck is not only model quality anymore, it is execution. A model can reason about a task, but useful work usually needs files, tools, state, and a place to run commands. OpenAI's update is about that missing layer. It adds a computer environment to the responses API, using hosted containers and the shell tool so an agent can do more than produce text. That is the immediate reason to care. This changes what developers can ask one API call to coordinate. But it also changes the operating model. You are no longer just calling a model. You are depending on a runtime. So the real question is not whether agents sound exciting. It is whether this setup reduces glue code enough to justify the extra system surface. The core change is simple to say. OpenAI equipped the responses API with a computer environment. In practice, that means an agent can use a shell tool inside hosted containers and work with files, tools, and persistent state in a more structured way. The company is not pitching a new model here as much as a runtime layer around models. That matters because a lot of agent work has been hidden in custom orchestration code outside the model API. Teams have had to stitch together sandboxes, file systems, execution policies, and session state on their own. OpenAI is trying to pull more of that inside the platform boundary. So the product move is not just more capability, it is more vertical integration. The API starts to look less like inference plumbing and more like managed agent infrastructure. This is where the update becomes more than a technical footnote. Once the API owns the execution environment, OpenAI can shape how developers build agents end-to-end. Hosted containers mean the platform can standardize security boundaries and scale patterns. A shell tool means tasks that need command line execution can happen closer to the model loop instead of bouncing across separate services. State means the agent can carry work forward without every developer inventing the same session architecture. That can make agent systems faster to build and easier to reason about. But there is a trade-off. Convenience grows when more sits inside one vendor's runtime. So does lock-in. The product tension is clear, less integration burden for the developer. More dependence on the platform's assumptions about tools, isolation, and workflow design. A lot of agent announcements blur together because they promise autonomy without explaining the execution path. This one is more concrete, but some caution is still useful. The presence of a computer environment does not by itself prove strong real-world reliability. Hosted containers, shell access, and state management solve infrastructure problems. They do not automatically solve task planning, validation, cost control, or failure recovery. In other words, this can make agents more operable without making them universally dependable. It is also easy to confuse platform completeness with product maturity. Developers still need to ask basic questions. How predictable is execution? How observable are failures? How expensive are long-running tasks? And where are the security boundaries in practice? Those answers matter more than the phrase agent runtime. That is where signal will separate from packaging. The best way to read this update is as infrastructure strategy. OpenAI is moving the responses API from model access toward managed execution for agents. That is meaningful because it targets the awkward middle layer between model output and useful work. For developers, the upside is obvious: fewer custom pieces to assemble around files, tools, state, and secure execution. For the market, It signals that the competition is shifting from model quality alone to runtime design, safety boundaries, and developer ergonomics. What changed is not magic. It is the platform molding more of the agent stack. Why it matters is also straightforward. The teams that control execution environments may control how agent products are actually built. What is still noise is any claim that this alone settles whether agents are broadly ready. It does not. It just makes the architecture more real.